Hello everyone, good evening to the very special audience assembled today. Welcome to another webinar of Codbo. I am your host Khushbu Manchanda, Growth Marketer at Codbo. In today's webinar, we'll learn how to develop software while keeping invariance in mind, which is one of the new software development techniques known as invariant driven development. Before we proceed, I would like everyone to put their hands together for our speakers for today. So today we have Shashank Shekhar, currently working as engineering manager at Codbo. Shashank has a strong background in managing engineering teams and projects for more than 7 years, delivering web services, cloud-based solutions, and security-based solutions using Python and related frameworks. Presently working in highly iterative agile environment to release major features and own the software delivery from concept to code to production. Using best practices for high quality software development, DevOps, microservices, REST APIs, and SaaS. Let me introduce Divyang Disa, another speaker for today. Divyang is currently working as senior backend lead at Codbo. He has overall 7 years of experience in the IT industry. He has contributed to the development of scalable SaaS products in a variety of industries, including EdTech, FMCG, FinTech, community applications, etc. He has a lot of expertise in developing scalable architecture designs using microservices on the AWS cloud platform. He has developed large-scale apps using Flask and Python 2.7. So without any further ado, let's just jump straight into the discussion. If you have any questions in between, kindly ask them in the chat so that we can, answer them at the end. So let's just get started. Over to you, Shashank.
Welcome, everyone. Good morning, good evening, whatever time zone you guys are in. So invariant driven development. This concept that we'll be discussing today was being used in past, and then I think test-driven development became very popular as Agile became very popular. But the kind of approach that we'll be sharing today looks similar to a test-driven development approach, but parts way after a point, which we'll be seeing. But moreover, I think this approach goes well with present agile and test-driven development that all of us are part of, majority in the entire IT and software ecosystem. So to begin with, I'll be starting with a quote. The bitterness of poor quality remains long after the sweetness of meeting the schedule has been forgotten. Now, in today's day and age of rapid development with small sprints and quick delivery expected, quality is something which suffers a lot, depending on what methods you utilized to develop, how was the contract that you received, and it has a lot of dependencies which cause quality. Okay, sometimes if done in a very rapid way, but following a right method, you would not suffer any quality. But mostly what we have seen is that bitterness of quality remains long after the enjoyment or the sweetness that you get after delivering any functionality, any software, any project on time. And this is one of the major concern which bundles up as tech debt, which is there in almost every project. There are rarely any project which does not have any tech debt, but this contributes to a majority of it. And this is also something which we want to see, like how if we adopt approach that we'll be discussing today will help us in guaranteeing or assuring a certain part of application, okay, that is not bound to fail. And another one that we see very frequently, which comes hand in hand with quality, is around bugs. Okay. And what is true of every bug found in the field is that it has passed all of the tests. Okay. It passed unit test, it passed QA, it passed UAT, it passed everything. But when it's in production, an incident has been reported, a bug is reported, and this is something which every one of us are familiar with, especially people who are developing software and delivering software on a regular basis. Bugs are something which gets past all the stages of testing that you do. Some you are able to catch in QA, some you are even not able to catch in the QA and the test cases that you create. Okay, so let's try to understand what is an invariant. Okay, the concept of invariance and how it should be used is very like it was defined in very much detail if you have studied domain-driven design, which we covered in our last webinar, where we gave a brief about domain-driven design, how it should be executed and what should be the process for it. Now, invariance is something which we can call it as a logical guarantee about the application. Okay, a property of an entity that remains unchanged throughout the lifetime of that entity. Okay. Or like in terms of object-oriented programming, it refers to some set of conditions or assertions that need to hold throughout the life of an object of a class. Okay. And like more in a broader sense, in the context of computer programming, it can be seen as a set of assumptions. A piece of code takes place before it is able to perform any computation of importance. And if those assumptions aren't actually true, the result of the computation is meaningless. Okay, so or more appropriately, like it's kind of a guaranteed that the result is correct. How do we plant in a logical guarantee in our application? Okay. So to understand like why invariants are important in programming. So invariance in general is a property of your data that you expect to always hold. Okay. And it's not something which will rapidly change as computation is performed. So invariants are important because it allows us to separate the business logic from validation. Your function can safely assume that they are not receiving invalid data. Okay, then only computation makes sense. So for example, we can take an example of a chess game. So you have invariant that only one piece at a time may occupy a given square on the board. And invariance can be enforced at build. Okay, representing the board as a matrix of optional pieces. They can also be enforced at runtime, okay, by raising any exceptions when we are trying to make a invalid move. So and continuing to functional programming, like approach and functional programming is typically to make objects immutable and prevent the construction of invalid states. Okay, so either it is functional programming or like in OOP, where objects are commonly mutable, methods are expected to prevent invalid state transitions. And either way, enforcing invariance ensures that your program is always in a predictive state and makes it easier to reason about your code and safely make changes without introducing regression. Okay, and that regression takes up a lot of time a lot of bandwidth, a lot of your time which you can utilize in much better ways when it comes to adding quality to your delivery. Just okay. Sorry. All right. Now, this was invariant, and you might think that this is same as validations, right? We write validations and we validate objects in our code. Is it different? So people like often view input validation and invariance are different concepts, especially like invariance was majorly previously used in C, C++, Java, those kind of programming languages. And now functional programming becoming very popular. We use validations a lot in that. But in fact, they are exactly the same. Okay, you wouldn't validate input data if it wasn't for application invariance. Okay, so for example, like when you check email address validity, it's there only because your problem domain requires all email addresses to adhere to certain rules, right? So email has a certain set of rules that it has to follow to be an email. Okay? And these rules are invariants. These rules will not change. Okay, until altogether the email technology and how email addresses are structured changes, this invariant is not going to change on its own. Okay, and like they define the concept of email address in your bounded context. Without them, so without them, the email address would like cease being an email address. For instance, a string without an @ is not an email. Okay, so difference between like input validation and invariance is just a matter of perspective, and it is also both of them are part of the same system and very closely coupled, which we'll be seeing next. In terms of, let's say, if you know a bit about domain-driven design, there's something called as domain model, and on top of domain model, we have application services. So to give you guys context about domain model, so domain model is a model which captures the rule, behavior, business language, constraints for a single bounded context, or like business microservices that it represents. Okay, but in domain model, we use business rules as invariants. Okay, because here business rules does not change. But when we talk in terms of application services, which runs on top of domain model, but domain model is still the core of it. Now the application services views businesses rules as input validation. Okay, so they validate the input from the external layer. Okay, or either from the external services or from the external layer where filtration is done before it reaches to the domain model. Okay, the core. So the business rules manifest themselves as invariants in the domain model and as input validation in application services. The same business rules affect both the domain model and application services, but in different ways. Okay, so domain layer views them as invariants, while the application layer as input validation rules. So we can take an example of something like, let's say, you want to, you have an API where you want to update the name of any particular profile. Okay, and you receive the name. Now there is an application service, and there will be a core domain model where it will be creating the setting of the profile name. Okay, and adding it to the database. Okay, maintaining it. So you must have defined the database, and you must have also defined that the name cannot be null. Now this invariant becomes the business rule, where the name cannot be null. At the application service, when you are getting name from the request, or it is typed on the screen, you will be also validating that the name entered should not be null or should not be white spaces. It should be some character. Okay. So that is one scenario where, like at the application service, when you receive such input, you will give a bad request and tell that, okay, the name is not valid, or the name is not null, or the name is null, so you need to enter the exact name, or the name is white spaces, whatever you will handle. Okay, you will handle the exception. But what if that exception does not exist at application service? Then, or if it passes the filtration, let's say we have set defined name. Okay, name cannot be null, or also name should be more than 5 characters. Okay, if we set such business rule on our domain model, then if we are not filtering at application service and giving an exception to this, then it would go to domain model and application is bound to fail. Okay, because you'll try to create an entry, but it does not satisfy the business rule, so it will fail. And if you are integrated with another system, since your system itself don't know what happened or is not handled, the other system will not be also be able to handle. Let's say if you are integrated to a front-end service, then the back-end service will return some absurd 500 error, which front-end will never be able to understand, and it is never handled. And these are the things which are logical guarantees, because it is set by the business rule. And this needs to be validated at the application service as well, not just on the like where the business rule invariants are set. Okay, so moving towards what is invariant driven development, I would like to pass on to Divyang to continue from this slide and help you guys with examples on how invariant driven development can be implemented on whatever project that you're working on, you're developing. Over to you, Divyang.
Thanks, Ashank. Welcome, people. So basically, to understand the invariant driven development with a code perspective, right? That's the next section that we would be dwelling into. And if we see, they are going hand in hand with the domain driven design. And most probably the first and foremost go-to point in any invariant driven development is the invariance, or identifying the invariance, right? So what are the invariant of your code that you're thinking of? So just to give you an example in layman terms, right? Let's say we have a circle, right? A circle cannot have a radius which is less than 0. Right, it is every time a positive integer, so that specifically is an invariant, right? Let's say if I have a specific application where we have to draw a circle, you have to provide a number, right? And it should be a number, it cannot be a string. You cannot have ONE1 or TWO2. It needs to be an integer, or it can be a floating point value, right? So if we see in that perspective, so we have identified what's the invariant and what's the validations, and what are the I would say the specifications that needs to be provided when I am creating an object of class circle, right? Let's dwell this into a Pythonic way to do it. There are 3 concepts to dwell into this, right? And these 3 concepts are majorly on the data classes. Then there are enums, and then our rudimentary and your classical approach of having classes and objects. Since Python has don't have that capabilities of building out an interface and proceeding further, but we have the concept of constructors and destructors, which is automatically getting destructed once the object is created. In the same way, we'll see through these slides what exactly are there. So as specified here, the first and foremost point is to identify the desired invariants. The next thing is we have to enforce the invariants, and our code base, or whatever the code practices that we are doing, it should basically round about or circulate according to the invariants to think in the mind. And rather than moving this invariant driven development into test driven development as we progress as we progress to the end, right? And we can refactor if necessary whenever it's required, because based on the business logic and compliances and other changes in the dynamic changes in the application, there are definitely important ways to refactor where your invariants might also change, right? It's not mandatory that invariants are constant, but if I would say as an entity, they definitely remains constant for a specific duration of the time based on the business logic. Moving on to the next slide, where I would be giving the example of an example of an imaginary pizza maker. It is more of an hypothetical over here, right? This can be found out on the references we would be sharing. But if you see through this this Pythonic code, right, I'll just brief it down one by one so that we can understand what exactly were the invariants that we were talking about, right? Uh, and there are basic concept of a pizza. What are there? You have a base, you have a sauce, you have a topping, you have the cheese on the top, and you bake it, and the concept is done, right? Your pizza is ready. Now there are multiple invariants in this as well, right? You cannot place your sauce above your toppings, right? You cannot place your cheese at the first level. Depends on the scenario, but let's consider this to be our invariant scope, right? And at least one sauce should be there. That there is a specific condition for it. Without having a sauce, you cannot create a pizza. Moving on, a dough radius, whatever is there. Generally, none of the cook is measuring with a compass. Said, okay, this is the size of the dough I need to make. But there are specific set of dough which are available, and these are whole numbers. So these are basically analogy of invariants that we are trying to create, right? It can be between X number to X number, right? When you have a pizza ranging from small, medium to large, there are specific confined radiuses of the same, right? You cannot have a 1 meter long pizza, right? Which is hypothetically impossible to achieve, right? It can be, but I haven't seen so far, right? So let's dig deep into the pizza specification class. As you see, we have an init function. As you're aware that it's a constructor function. We have already provided the constructor, basically the variables or the parameters of the class which needs to be defined. And we have dough radius in inches, we have toppings, and ideally toppings are defined as a form of list, like list of string. And when it is list of string, it is not list of integers or list of floating point values. So we have confined that this is kind of a specification that we are looking out for. So ideally, this pizza is basically taking up two parameters. One is the topping, and another one is the radius of the dough. Moving on to next, there's an assertion. So you would be seeing two approaches while doing this specific example. Another one is assertion, and another ones are exception, right? Assertions are mostly we are aligning in the development process where we are doing when we are writing out the test cases in order to compare. But assertion can also be used in cases of validations as well, right? Rather than having a sequential way of approach where you use sequential statement, we use serializers where if and then we have a sequential construct. We basically can have these kind of validations in place at the class object level, right? The only thing which I want to specify here, and we have been abstracted from the nature of object-oriented principle, is abstraction. See, these are specific processes which are hidden or encapsulated under these hoods, where underlying these are the processes which or the coding practices are definitely taken care of, right? And parallelly moving further, where you have assert where your door radius is less than 6 and greater than equal to 12, or less than equal to 12 and greater than equal to 6. So that's the range that we have given. Tomorrow, this specific range can change as well, right? So what exactly happened here? This became a constant, and this constant we need to use another universal global approaches where these can be configurable. Moving on to next, where you have sources, where sources are again, a source is a specific class or a function which can be imported, where you can have n number of sources. We cannot make it as a constant, but it dynamically changes. So based on that, if you see the sources, we have a specific loop from the toppings, and if that specific source belongs to the T, that is done. And in this specific way, you have another length of sources which should be less than 2. right? It cannot be more than 2. You cannot create a pizza having 5 multiple sauces, right? I don't know how it's going to taste like. Fine. So moving on to next, so if you see the the constraints or the invariants that have defined, the same invariants have been systematically approached here as well, where all these specific code practices have seen. Now, when I'm going ahead and creating an object, when I'm going ahead and creating an object of the pizza specification in order to go ahead and create one order, right? I need to make sure that these specific parameters are passed, right? And you can co-align this with data classes or the pydantic models, which are generally getting which more of the coding practices we are currently using now, where we have our validators in place, we have our exception handled, what are the validations, and you can have custom validations in the data classes as well. So this specific, the concept of pydantic principles can definitely be covered as we progress in our further few more I can say seminars. But let's limit this to here, and let's move on to the next slide, which will be talking about the second step. As you saw that the example was there, we have identified the desired invariants. We've also provided the concept of class invariants and got the step done, right? Moving on to the next step, which specifically is can we move? Okay. So after identifying of the desired invariants, these are the specific state of them, right? You have the initial state, you have a retrieval state, you have a success rate, and you have an error rate, right? So if you see the initial state, the user coming across to create the custom automated object of your pizza, right? So you have abstracted the entire pizza process. You just have to pass it to the black box and you get a specific object. So there would be few, I can say a user input kind of implementation, which can give you the specific scenario. Let's come on to the next one, which will be the retrieval state. Like once a user performs a search within a class, there are defined methods in the same process, and we have to actively perform the request, because it might not be a single object that is created. There can be multiple objects that can be created, and we have to also create fault tolerant system in such cases, right? After an object is created, we specifically see through the success state where exactly the product that or the object that we were looking out for with the specific specifications given, right? Have we got the required pizza or the order or the class object once the object was created, right? And then last one, which is really very important, is the error state, right? If the object creation fails, right, then we should show the user an error message so that they understand there was a problem in executing the specific object or creating that object of a specific class, right? There can be, if I give you an example, let's say if I had passed any incorrect or undesirable inputs for the creation of my pizza specification class, definitely it would have thrown the error. There is an error which could be annoying to a user, right, or annoying to a developer. So we have to gracefully handle through those validation errors, and that's the point where we get into picture, where we have custom exceptions, we have custom error handler, and so on, right? So these are the four steps which we need to identify when we are doing the when we are doing the invariant driven design, right? And invariant driven design it cannot contradict, but you can correlate the same into basically into a validation, but not strictly validation, because this will definitely help us during a unit test case writing, right? Moving on to the next, where step 2 was to enforce the invariants, which we have already done. We have already discussed this specific part in the code bases, what exactly we are doing. We have the door radiuses in inches as an integer. The code is asserting that how many sources are present, the topping list, presumably all the steps that are required, what we defined in our invariants identification. all the specific steps were closely taken care of in the creation of the class, right? And the step 3, which as we discussed is mostly is refactoring the code, right? Why it is necessary is because first, it becomes very much important once the object creation dynamically changes, or our application or a business or a software development application changes from time, right? In those specific sense, it becomes very utmost important to have a universal and a generic structure, so that it becomes easy for us to change. It becomes easy to add invariants and to handle those invariants appropriately, rather than doing your code and making the reducing the readability of the code, right? So that's one of the reason. We'll also as we proceed further, we will see why specifically when we do an invariant driven development, what it is helping us, right? As everyone is aware about of Python's principle or the Zen of Python, the first rule is keep it simple, right? And do not repeat yourself, right? As we see, the first thing over here is happening. We have a generic specific identified invariants, right? Which would be taken care of, right? So that we are not littering out our code, where we are doing all the checks before an object is getting constructed, right? And every place, right? Even though we are having a function where our things are specifically written and we are just using those functions just before the object creation, right? It also is making your code bulky because it was totally not required. It could have been taken care of once the classes and object creation has taken place, right? If we start working with Pydantic model is a very, very good example of considering the invariant way of driving out the code. And second point, if we move on, right, it is much more related to a developer friendly, or how is a writer writing the code, the maintainer, the reader, and once you pass on this specific code to another, how you have worked on, right, it would be providing lesser burden for all those coders or the developers who would be constructing the further part of the code and adhering to these kind of principles that that have been shadowed from a really long while, because of multiple changes in the software development cycle, where major of the stuff is getting abstracted as we pass on, right? So majorly the basics have been taken a hit. So just to revive the specific processes and start working on providing much more of a custom class is the entire goal what we can achieve using the invariant scope, right? And definitely the last one, like when you see such kind of a high quality and high quality of code driven design, and we have the invariant as well, this will also be merged into a test driven approach where your testing capabilities and your way to unit test your code will change drastically, right? You'll have a clear clarity right now. If the code is written in this manner, it becomes much easier to do the assertion and increase the code coverages. If these processes are not inbuilt, right, then it becomes a tough task. There's an equal amount of time that you have to spend, which is almost equivalent to writing out the code, right? uh, Either it can be through mocks, either it can be to PyTest, unit test. There are multiple testing packages available in the market, which Python packages which you can use in order to get the test driven development. So the next slide I think would be on the test driven approach, right? Which Shashank would be taking care of. Yeah, Shashank, over to you.
Yeah, I think that was a great example, Devang, which you shared, and very simple for us to understand. And like people who are developing front end or working with any JavaScript library, this remains same, right? Whatever logical guarantees that you can put inside your implementation, be it at application level or your model level. So this fits very perfectly in picture with test-driven development. Okay, they are not mutually exclusive approaches that either you do and invariant driven development or test driven development, this invariant driven development aids a lot for you to easily perform test driven development. Okay. And test driven development, as I have seen through my experience, is a form of development which definitely takes a lot of time when you are thinking of all the unit tests that you would be writing up the unit tests, performing the checks. So those take a lot of time. And also, if you are placing a logical guarantee within your code with invariant driven development, it secures your code for the future as well. Okay. And rather, the goal is to obtain invariance sooner than later, like even before test time. This can yield a few benefits for you and for your application to be more stable. So if we want to see like how this aids, is that there are fewer tests to write. Definitely, if certain bugs are made impossible because the compiler will not allow them, or you will not face those errors unhandled when you are using any specific API or any specific application, then this also helps us in writing fewer test cases, because you know that certain tests are bound to fail because or bound to give you an exception, because logically we have put in guarantee on that it will not pass the function for computation. It will reject at the invariance validation itself. Okay. And invariant first approach produces holistic solutions. Okay. Unfortunately, writing test cases first may introduce implementing details that originate in narrow focus unit tests. But this invariant first approach provides a very holistic solution to the software that you are writing. And a lot of invariants your IDE can help and leverage the system that you have in. If it is a compiler that you are using, if you're writing program in Java or any compiler-based program, then that also aids you a lot. But if you are doing, let's say, programming in a language like Python, then you have a lot of modules and IDE plugins that help you leverage the invariants and help you leverage writing invariant first solutions. Now, moving to the last part of our webinar is around, before we open for question and answers, is around what do we conclude out of this approach. Definitely, invariant driven development is not the only approach that you should opt for. Okay, there are hundreds of different things that you have to care about when you are developing and you are delivering. But this invariant driven development is more about viewing bugs as they really are. Okay, identifying them at a very early stage. Okay, and putting in a logical guarantee that if something comes in which tries to break that logical guarantee, it will not be able to perform any action. We will be throwing an exception or putting a validation to not pass through. Okay, and a bug is an application guarantee that isn't being enforced. Okay, and it's also about approaching development through the lens of identifying a guarantee first and enforcing that guarantee. Earlier enforcement is generally preferable, such as leveraging the type systems to get compile time enforcements, or when you are writing up, or let's say there is a class invariant being introduced. Okay, if you're talking in terms of Python, before it computes the function in it itself, the entire request would be rejected if wrong input is provided or invalid input is provided, which is not as per the business rules. Okay, because on the core layer, or at the layer of application service, the business rules is something which is invariant across. Okay. So application service, when they are doing filtration process of request, or when they are doing validation of the request that is received, they will softly reject the request and throw an error. At least the user will be able to understand that there is an issue and what needs to be corrected. Later enforcements may be more practical, okay, and this can be done by using test-driven development, of course, for that particular guarantee. But lastly, refactor the code when necessary, and this is very important. Whatever we do, one of the mission should be that we look at the code and refactor. It's not only for if we are trying to do any new development, but also refactoring the present code that we have already written and placing in logical guarantees for a more robust solution.